Okay. Hi guys. This is where we left off last time. Okay. And what we are basically going to do is going to modify this program and write it in a bit different way. Okay. Uh, what first thing we're going to do is we're going to replace this while loop. Okay, with a for loop. Okay. We're just going to understand how a for loop works. Okay, it works very similar to a while loop, okay, but it's a bit different. Okay, one more thing that will happen is we'll make this program really very small. Okay, let's see how we'll go ahead and do it. Okay, let's replace it with for loop, and as we go ahead I'll explain how this for loop works. Okay, this for loop is basically has three parts. Okay, one is first part is called as the initialization. For example, I'm going to initialize dollar equal to 0. Okay, it's going to be executed only the first time a for loop is entered. Okay, and then it has the condition. Okay, this one, it's going to be executed every time the for loop is entered. Okay, as exactly the same way as the condition in while loop. Okay, and it has an increment part where I'm just going to do this. It's what this one is, right? I can just place this here. Okay, remove the semicolon. Okay, so this is how our program will get a bit smaller. Okay, one thing is, we have the initialization, now you have the condition, and then we have the increment. Okay, and everything is the same. And one more thing we can do really is, let's just try to eliminate a lot of variables. I think we have too many variables for a very small program. Okay, so what we could do is, we could do this arithmetic expression in place inside a printf statement itself. Okay, let's do that. Okay, and this statement is not needed. Okay, and as I had explained, right, as a while loop, we can have only one statement without this open brace, open curly brace and close curly brace. A for loop can also have a single statement without these two, so let's remove them. Okay, we have a single statement. Okay, and another thing, we could remove the variables here is, okay, lots of variables we could just remove. Okay, step one, and okay, we have removed quite a lot of variables, and just remove this corresponding variables as well. Okay, we have removed a lot of variables here. Cool. Our program is really very small. Okay, we have just one variable here. Okay, we have just defined it as int, and that is what is the thing we used in our for loop. Okay, we've declared as dollar as int, and we'll start with dollar. Sorry, it should be 0, it should be 1. Okay, so dollar, you start from 1 and it go till 4. Okay, if you need till 5, you say less than equal to. So from 1 to 5 you print all the values of this thing. So this is how it works. Okay, so the first time, for dollar equal to 1 gets executed. Now dollar is 1, so now this condition statement gets executed now. Okay, and after this condition statement gets executed, whatever inside the for loop gets executed. That means this statement. After this statement gets executed, what happens is this increment statement gets executed. Now previously dollar was 1. After this increment statement, now dollar will be 2. Okay, now after dollar will be 2, now the condition statement gets executed. The work of this initialization statement is over now. Okay, now this condition statement is executed, so dollar is less than 5, that is 2 is less than 5. So now what happens? Now this printf statement gets executed. Okay, after this printf statement gets executed, again this increment statement gets executed. Now dollar is 3. Okay, and 3 is less than equal to 5, and again this printf statement gets executed. Okay, after that dollar is again incremented to 4. Okay, 4 is less than equal to 5, and then this statement gets again executed, and dollar is incremented to 5. So 5 is less than equal to 5 because 5 is equal to 5, and then this statement executed. Now dollar will become 6. Okay, when dollar is 6, this statement is false, and then so the statement of execution of statement exits from this for loop. Okay, and after the for loop there is no other statement. Okay, so it exits the program. Okay, so this is a very simple program now. Okay, so we have actually very simplified the program too much. Okay, and there's one little problem which we're going to fix before before we are completely done with this program, because I think we have spent a lot of time with this program learning a lot of concepts. Okay, we have almost beaten it down to death, and I really don't want this program to die. Okay, so one small problem. Okay, we're just having a lots and lots of magic numbers here. Okay, there's one small mistake here. This one has to be 42.3. Okay, there's a lot of magic numbers here. Okay, so like, what are magic numbers? These one, okay, this, okay, and this. These are just numbers. Okay, for example, right, if the exchange rate changes from 42.3 to 43.2, I have to go inside the program and search where all these things have used, okay, and change them. So it's actually very bad practice. So instead of that, I introduce a new concept called as symbolic constants. Okay, we will define constants which have names. Okay, these are not variables, these are actually constants. Okay, so what happens is, when before a program compiles, there's something called the preprocessor. Okay, so what it does is, any constant it sees. Okay, let me show you how it works. Hash define. Okay, let's define this thing. Okay, so it's a common practice for this all the symbolic constant. These are symbolic constants, and this is the syntax how you define them. Okay, you say hash define, and then whatever name you want to give the constant, and whatever value of the constant you want to give. Okay, it can be integer, it can be floating, it can be string, it can be anything. Okay, hash define exchange rate. Okay, 42.3. Okay, as I was saying, all these symbolic constants, okay, you can substitute them for either float, integer, float, string, anything. Okay, anything, and you could use them anywhere in the program. So what happens is, whatever you have substituted them for, right, for example exchange rate, will just simply get substituted by 42.3. okay, actually what goes to the compiler is 42.3, not exchange underscore, right? Okay, it's a very easy way of hash define, easy way of making your programs very much readable. Okay, so let's make it much more readable now. So exchange rate, okay, so we just have a really long for loop here. Okay, so we just going to split it in two different lines. Okay, to understand this. Okay, so this is how I'm going to substitute all the variables here. Okay, so what I've basically done is, instead of 1 I have placed init $. Okay, and instead of 5 I placed up underscore $. Instead of just 1, again dollar stepping up by 1, I placed it as step, and with all these things I have defined it here. Okay, and another thing is, I can place this 42.3, right? It doesn't look good. Exchange rate. Yeah, I placed exchange rate here. So what basically this happens is, the program is very much readable, and we can easily modify. It's easily modifiable. For example, exchange rate changes from 42 to 3 to whatever, 42 to 2. Okay, you can easily modify it. Okay, so you have all your modifications at one single place. Okay, I don't have to go all over the program and search where all my constants are there and go ahead and modify it. I can modify all this here. Okay, Okay, so that's what I would want to tell you with this program. I am almost done with this program. Okay, so with this we are done with this exchange rate program. Okay, we're going to do something different next time. Okay, so before just closing out, let me just you know, run the program and show you how it works. GCC exchange rate v4, that's what I've stored it as. Okay, and okay, see, you have 5 this one and neatly displayed all your this one. Okay, so with this I'm done. Okay, let's get to a different program next time.